Hello, everybody. Welcome to my talk. Just got to get this thing sorted out. This clicker doesn't work. I blame Raphael entirely for this. I'll try turning it on, actually. That will probably improve my chances. There we go. Wonderful. Hello, everybody. This is loads of people. I don't think I've ever spoke to this many people, so thank you for having me here. This conference is amazing, and apart from trains in Serbia, I've really enjoyed my time here so far. The trains are not okay. I'm here to talk about REST APIs. Actually, no, I'm not. I'm here to talk about APIs in general, and something that people do quite a lot is they act like REST is the best thing in the universe, and like SOAP and everything else is pretty bad. And I used to be pretty guilty of that myself. Sorry, a bit of feedback here. There we go. So I wrote a book a while ago about APIs because I've spent a lot of time over the last few years building APIs. It's pretty much all I do. And I learned a lot. I've done 2 jobs in a row where I'm just exclusively working on building APIs. And I wrote the book about the kind of my experiences at the first job. And I ended up doing a talk called API Pain Points, which some people might have seen. I did it like about 5,000 times last year, I think. So this is a new talk about stuff I've learned since then. So, REST. It's wonderful, but it's not the only thing around. There is SOAP, and it's not bad, it's just really annoying. This is one example. If you Google search for, if you search SOAP example, this is the first thing that comes up, which is incredibly clear and self-describing. SOAP has its uses. SOAP is kind of a layer of complexity added on top of the basic XML RPC format, which XML's kind of crap at describing data types, so they thought, we've got a problem with this XML, no one really knows what it is, let's put more XML on top of our XML, and you end up with nonsense. So the idea of XML RPC and JSON RPC isn't bad. It's a little bit more complicated. Like with JSON, with REST, one thing you can do is just like JSON decode, file get contents, a URL, and then you're done. So people think that REST is more simple, but once you start to grow, you end up with problems. And people have ended up like reinventing WSDLs like this, just JSON schema and other stuff instead. So it's a bit of a weird situation. But people treat REST like it's a metric of quality. I've heard a number of people that say, we're building an API and we want it to be good, so we're using REST. And that's kind of strange. Some people try to tick all of the boxes to generate a REST API and don't really know why they're doing that. They've just said that REST is good, so they're going to give it a go. But REST is really hard to do, and it's really hard to do properly. So a lot of people don't actually do REST properly, but want to have that API considered good, so they just say it's REST, and then it isn't, and you have this really weird situation. It's kind of easy to understand why people think that REST is the best thing in the world, because the Richardson maturity model makes it look like that. I mean, at the bottom, we've got Swamp or POX, and that is RPC, right? POX sounds bad, and Swamp sounds bad. And then at the top, you've got this little halo, which is glory. And everything in between is kind of steps on the way to changing from RPC to REST. So do you actually need REST at all? Like, is it important to you? Maybe RPC would be a bit more appropriate, and I'm going to show you kind of why and how sometimes RPC might make more sense. So the R in REST stands for resources, and the C in RPC stands for commands. It's remote procedure, oh no, it's remote procedure calls, but the remote procedures are basically commands, events, and actions. I have done this talk before, honest, hang about. Yeah, so with resources, basically you're modeling your domain, your entities, all of these kind of resources domain, all that stuff means the same thing. You're modeling the data as it kind of fits and the relationships and everything else. But with commands, you're just saying like, do this thing, and it's not really, they're not the same. And if you try using REST for something that is command-based, it sucks. And if you try using commands for something that's kind of domain models and entities, then it also sucks. So maybe you could add a slide that isn't blank. So here's an example of the same basic CRUD actions with both approaches, and I'll get into more interesting stuff in a minute. But basically, with the RPC approach, you only really use get and post, and that means that you have to kind of put the action into the actual URL. So if you want to list something, you put list in there. If you want to create something, you put create in there. And with REST, you don't need to do that because you get to utilize the entire spectrum of HTTP verbs, of which the most common are get, post, patch, delete. But that's nice and easy when you're talking about CRUD, create, read, update, delete. When you're doing those things, it's really simple. But when you get onto maybe consuming a cheeseburger, because it's all well and good having these cheeseburgers, but you have to do something with them at some point. You need to put them in your face, and to do that, you need some sort of consume endpoint. But where does that fit in REST, right? This is an XML approach, something people used to do, still do if you use SOAP. And they will say, we've moved off cheeseburgers onto something slightly more useful. But maybe they want to send a user message, right? You have the same idea. You can create your users and create your messages. And they'll have a content type, whatever. But they say user ID 5 and message hello, because you need to know what user you're sending what message to. Now, if you want to make this a bit more RESTful, you can quite simply use sub-resources or kind of sub-endpoints. And you have users/5 that you can get on. You can get users/5, and you have all the information, and you can have send message. But this is still a random RPC style endpoint in your REST API, and that's really weird to do. So you can just simply create on a collection, and it's kind of the same thing. The benefit of doing it this way is that when you do get, you can get on users/5/messages, and you'll see all the messages that have been sent. So you have this kind of like consistent approach to your API that makes a lot more sense than these just arbitrary endpoints with arbitrary commands. A slightly more interesting example than that is state changes. So at Ride, I work for a company that does carpooling, where you can match with other people that want to drive to work to save the planet, and you can plan trips, you can start them, you can finish them, and you can cancel them. So we got to the point of working on these endpoints, and people were thinking, well, how do we actually start these? I mean, we've got the CRUD endpoints for all this stuff, but like, how do we actually say, I would like to start this trip? And the first logical choice to many people on the team was to just bang in a start endpoint, which is not even vaguely RESTful. And I keep sort of saying, like, oh, it's not RESTful, but like, if you're going to have a REST API, it should be entirely RESTful. It's kind of like me speaking English and then just randomly doing a bit of French halfway through. Like, probably people wouldn't like that. And I can't speak French, it's terrible. So we got start here, and they want to have finish there, and then cancel there, which seems kind of logical, right? But the only reason they were doing this was because they wanted to have, in the controllers, they wanted to have a little method called start, finish, cancel, whatever, where they could execute the business logic that would do that stuff. And that is like passing a code design choice onto the API design, which is a really weird thing to do. So in the end, this is about where the Stargate images start popping up. In the end, we ended up using a state machine, which helped us out a lot with this stuff. So an example of that, you can patch on stuff. You can patch on any field that's editable. So you could patch the driver, you can patch the start time, but you can also patch the status. And you can say the status is now in progress, and that just starts it off. And you can say, I want to complete it and cancel it. And this is where I start trolling real hard, because look, it's Ruby. Doesn't show up very well, but what we're basically doing here is we're defining a series of possible states: location, in progress, complete. There's state machines for PHP. This just uses one that's in Ruby, because our API is in Ruby. And you define the states that it can transition from and to. So here we're saying we're going from locating to in progress, from in progress to complete. So you can't go from complete to starting off again, right? And the cool thing here is that you can put these like these transition clauses in. So you can say, after the transition from locating to in progress, then do whatever code you were going to put in your start method. So it's exactly the same as having that controller, but you get a few added benefits. Firstly, we don't have to put loads of code into our controller that says like, oh, the state is currently this one, and they're trying to go to there. Like, imagine the if conditions to work out how to let that pass through. It would be terrible. But regardless of that, like, even if you find a way to put all of the things that might have ended up being a little bit RPC style into your RESTful API in a way that's RESTful, sometimes a little bit of RPC sneaks in regardless. And this is one example. I really couldn't work out how to do this. So you can invite people, you can invite people to a carpool. And when you send them an invitation, it sends them a little code in an email. They can put that code into the app, and they can start riding with you. And we really couldn't work out how to make that work, because we're not creating a code, we're not really changing the status of a code. It got really confusing. And one of the things about making a RESTful API is not just bunging arbitrary fields into the kind of RESTful stuff. I really can't get my microphone worked down today, I apologize. So that one kind of sucked, and we have like this one RPC style endpoint, but sometimes it happens, and that's okay. Well, he's mad about it. There's a reason that Slack use RPC, because sometimes you have an API that's mostly RESTful and it's got a little bit of RPC, but if you notice that there's certain things that you cannot massage or force into the RESTful approach, you might not have wanted to use a REST API in the first place. RPC might have been the way to go, and with Slack, they have done it quite well. They have stuff like this. Has anyone worked with the Slack API here? Yeah, a couple of people. And what they do is quite cool. This is how things used to be done in like the 90s, but they don't really have entities as much. I mean, sure, there are channels and there are users and there are all these things, but they're not just modeling a set of documents and like adding relationships in. It's not pure CRUD. They're doing really complex things. So like things like kicking a user, leaving a channel, and banning a user, right, are all three very similar things, which if you tried to do an RPC, you'd probably end up with like a delete user endpoint. But delete is like the most appropriate thing to use for that, but it's not very explicit, because what does this do? Does this leave a channel? Does this like ban a user? Does it kick them forever? I mean, we could try bunging in a kicked status, and that's not really very helpful, because that status is applying for that user across everything, right? Like anytime you go to use this jerk face, their status is now kicked. But you could be kicked from one channel, but still in another channel, so that doesn't work, right? So maybe you could bung in like well, we're going to kick them from the cat gifs channel, but they can carry on posting dogs or whatever. But that's just whacking in a random field that doesn't make any sense in the context of the user. So we're kind of stuck. You end up doing some like real back-breaking nonsense like this, where you're just saying, well, we're going to delete them from the channel resource, the random channel, but it's going to be like the relationships, so like the users, and then, and at that point, you just probably shouldn't have used a REST API. I mean, even if you pass in a kick reason, you still don't know if they're I mean, you have to pass in a reason, which is still kind of like an arbitrary field that you didn't need to add there. So at that point, RPC might have been a better idea in the first place, and now he's happy because it's all fixed. This is what Slack do. So we're going to have a little look at Slack. They've got post, channel kick. They know that there's a moderator doing the kicking, and if they're not a moderator, they can be like, yo, you can't do anything here, 403. And we can shove in whatever random fields that we need, because it's an RPC. You just shove things in. RPC is just like calling a function in PHP. You can just call it anything you want, and you can put any arguments in you want, and then you just document how it works, and that's fine. Channel leave, again, different thing. We're going to pass in the user token here, which means that we don't need to pass in the user ID, because we can infer that from their token. This token will link up to a user in the database, and I am leaving myself, and I want to leave cat gifs. So that's all nice and simple. And ban, it's really easy. We don't need to say which channel it's from. We need to pass the user in because we're a moderator. Ta-da, it all works. So people always argue about which one's best, and it's the most daft conversation after tabs and spaces. They're both different things. Actually, tabs and spaces are the same thing, so that's even more daft. At Ripe, we actually use both, and a lot of people I know will consider that any app of any decent size will end up needing both RPC and REST. What we do is it's kind of complicated, so I don't know, hang on a minute. But we have the mobile clients, the iOS and the Android app over here. We use PubNub, which is like a two-way WebSocket. PubNub. Anyone use PubNub? No? It's kind of like Layer or some other stuff, but you can kind of connect to it, and you can do real-time chat with it and send messages backwards and forwards, but connecting to it's really hard, so our back-end systems go through a message proxy. Any message that goes into the PubNub will be proxied and turned into AMQP messages, at which point any of our services can subscribe to any AMQP message that's coming through that they want. Maybe the geo service that like watches where all the cars are and reports that people are picked up. Maybe they want to know that someone clicked the start ride button, right? And then the geo can talk to the API, the bot can talk to the API, everyone can talk to everyone, and the clients can talk to the API if they want. So the clients have the ability to like define actions that have started, but they also have the ability to go and like query the entire API, get any domain data that they need, and kind of see this whole treasure trove of data that they don't have to jump through RPC-style commands to get that data. Does that all make sense? Everyone nod, come on. So yeah, you can have both, and it's a good team up. We're on to the second half of the talk now. The first half is pretty much REST versus RPC, and the second one is just like random information and tidbits of things that aren't in any particular order, much like this show. You need to document everything. If you don't document your API, it just really sucks. Like, you'll spend a good half of your time telling people how that stuff works, and it's the easiest thing to do. Who here currently documents their API? Okay. Well, just so I know, how many people are working on an API at the moment first? Okay, keep your hands up if it's documented. Okay, good. Now, who does, sorry, you're going to get a sore arm. Switch arms each time. Who does the documentation by hand? Like with HTML and all that crap. Okay, and does anyone use any tools like API Blueprint or RAML? Good, you folks are onto a winner. If you use API Blueprint or RAML, you're basically writing Markdown or YAML. And you can document your API just by kind of marking out the endpoints and marking out the attributes. And the best thing about using these tools is that not only can you document it and generate PDF versions and HTML versions and all this other stuff, but you can actually run it through testing. There's a tool called Dread for API Blueprint, and we run our API documentation through that. It will look at all the example values and all of the endpoints and resources and fields, and all of the values that you've specified for those fields, throw it at an instance of the API, and then it will catch the response and make sure that the documentation you've written down lines up with what the API is actually returning. So you don't want to use that as your only source of tests, but it's like you have your unit tests and your integration tests, and then you have the documentation tests. Otherwise, there's no way of knowing if your docs are actually right or not. Right, you've got like this document over here which doesn't match that, and I get caught out all the time. We disabled Dread for like a week, and then we just every single day noticed that our docs were slightly out of sync because we're adding new fields and failing to update it. So documentation is super important, and don't leave it to last minute. You can actually document features first, which is a lot of fun. Hang about. Talk amongst yourselves. Documenting the API first. If you've already built an API, you can just adopt this approach for new features that you build. What we do quite often is we'll work on a new endpoint, and we'll document it first. And that documentation is just a little bit of Markdown like this. So we can quite easily say, all right, we're working on this schedule feature. So it's going to have a collection. That's one of the endpoints. And then here's one of the actions, which will be on there. So it's post, and then give it a name if you fancy it. And it's broken down into request and response. So you can put in the headers and the attributes. Now, who here works with API Blueprint? Put your hands up again. OK, it's a bunch of you. Is anyone using Emson? Because Emson is the cool thing that we've got here, attributes. You can either put the body in yourself manually and just dump like a whole block of JSON in there. But the problem with that is you have to keep like manually updating this JSON, and if you have really similar JSON payloads in multiple endpoints, then you have to like update multiple parts of your documentation, and that really sucks. So you can put things in like this, and we've got named data structures here. So we have schedule create and schedule full, and those are defined here. So we can say, for schedule create, it's just a markdown list indented. Here's the fields, here's the default value, here's the type, and here's the description. Then you can say inbound to, work is like the default value, and you can define your relationships. So doing all this stuff is pretty handy. We can use schedule create to show how the creation works, the post. But then once it goes into the database, the response is going to be the full object, because when you create stuff, you don't send all of the data, just some of it. And schedule full will just be the ID field, and we'll include the rest of it because it's all the same, right? Here's another bit of random advice. It's a little bit controversial. Maybe you don't need Hatios, which sounds like a kind of a supervillain serial to me, but it's the concept of hypermedia as a state of control. And Hatios is the last thing on the list. It's when you get your halo there. And it's something that a lot of people try really hard to wrap their heads around, and they try really hard to implement, and it's actually quite a pain in the ass to implement. But you want to be restful, so you just do it blindly a lot of the time. And Hypermedia it can be really helpful, but it's basically designed to make a REST API last for decades. How many of you work for a startup? My startup might not be around in 3 months. Why am I worrying about being alive in 40 years? I probably won't be alive in 40 years, especially with all the cycling I do in New York. Jesus. It's one of those things where basically you want to take some of the ideas of Hypermedia and put them into your API. Like, it's really good to put links to resources. When you have errors, it's really helpful to be like, here's a link to other information you can read. And you can put Hypermedia links the whole way through your API. But, I still have another slide there. You can put them the whole way through your API, but generally speaking, a lot of people will completely end up ignoring those links, right? Because the idea of Hypermedia, for those that aren't aware, is you call a resource, and then there's a bunch of links in there that you can fetch to go and get more data. Problem is, if you make one request and then have to wait for that, and then go and make another request, that takes quite a long time. So a lot of people, a lot of mobile developers especially, are very scared, paranoid, concerned, whatever, that their app will be slow. If you make more than one request, your app will be slow, which is fair enough. You don't want to make like 100 requests per page, but and you especially don't want to like wait for one and then do another one and then do another one. So they end up just like hard coding the URLs because they know where the other data lives. They know what the URLs are already, so they're not going to bother to look in the response. Does that make sense? I've seen this happen a lot. Like, clients just completely ignore Hypermedia, so it's not really the golden situation people think it is. Versioning is fun. Who knows? Who's ever tried to version an API? Yeah, it sucks. There's an amazing article by Troy Hunt, which is called "Your API Versioning is Wrong," and it shows like how every single approach to versioning your API can be done and why they all suck. The best approach to versioning, to like building an API that will last a long time and avoiding the need for versioning is just don't change stuff. But that doesn't really help. So. If you work in a rapid application development environment, like I do, and you work at a startup where they bloody pivot every 5 minutes and every time the wind blows, it doesn't really make a lot of sense trying to version it anyway, because a lot of the time, well, right, something that's pretty cool that happened. We haven't ever versioned our API. We released version 2 of the app, and we just deleted version 1 and didn't give a crap about it. Like, we didn't have enough users to care, so we just went, whatever. But version 1, we kind of did a little bit of stuff. We would semver the versions internally. No one ever saw that. It wasn't in the URL. We'd semver the application as we were working on it. And then every now and then, there would be some big change that was important. So we kind of hack in support for the old way and then wait 3 minor versions and then just delete it. And if anyone was still using the old version, sod 'em. So a really good way of doing that was, because we're at a company where they change their minds on a lot of things quite regularly, we changed from having the concept, we stopped calling them rides, and we started calling them carpools. So that was a great chance, because the rides payload was a certain way, and the relationships were a certain way, and you used to only have like one driver, and then they started calling them carpools. So we're like, oh, cool, we can just make a carpools endpoint and make it be the new way, and then we can just like support the old way. So when you put data into rides, in the background, it converts it into carpools, and then that's done. And we supported that for 3 minor versions, and then we deleted it. So we kind of have this like rolling thing. And again, like they changed from matches to recommendations. And we were like, cool, let's just support matches for a little while and get the hell on with it. That stuff works great for a private API, but it doesn't work very well if you have a public API, right? You can't just say to a bunch of people, like, you've released your API publicly and you've got changes happening, and you're like, well, we just changed it because we don't like you. But the argument there is, if you're a rapid application development environment, why are you releasing your API to the public? You probably want to stabilize your product before you start letting other people build on it. Otherwise, you're just being incredibly reckless and daft. So it's not really such a problem. Facebook actually used to do this stuff with feature flags, and it was pretty cool. Because Facebook would say, all right, we've got this dope new thing coming out. You should use it. And then it would just pop in after a while. And sometimes they'd say, oh, no, we totally screwed up on that. You shouldn't use that. We're gonna get rid of it. And you get an email warning, and if you ignored it, then your app would just break. And it's fair enough. Like, change is hard, but Facebook feature flags are a really good way of doing it. But yeah, now they globally version their API in the URL like they're 6. So one bit of advice that's not entirely like API specific, it's kind of service-orientated architecture specific, but it's kind of both. Never trust an application that only tests with itself. We've had this a lot at Ride, where we have like a billing system and an API and a geo system and other stuff, like a chatbot, because bots are cool. And the problem is that everyone writes a bunch of unit tests and a bunch of integration tests for their app. And they'll make sure that their app works perfectly fine with the fixtures that they've generated. So they'll save a copy of the API response that is accurate with the right JSON in there. And they will end up, they often keep that JSON response for a really long time. So the API can change, or other services can change over time, and it isn't reflected in the fixtures that they have saved in a .json file in their test folder somewhere. So unless you're actually running tests against the entire stack somewhere, maybe it's some automated testing environment, maybe it's locally, hopefully it's both, or it's like manually somewhere. But if the apps only test themselves, it's useless. You want to test the whole way, end to end, through all the systems. Good way of doing that is Docker. Hey, anyone? It's cool, right? Docker's pretty handy, but Docker's pretty much just like a machine manager. By itself, it doesn't solve the problem. What does solve the problem is using Docker Compose. Because with Docker Compose, you can say, all right, we've got all these services. They've all got this thing running on that port and this thing running over there. And they've all got these environment variables. And you can run the entire stack locally. That's one thing that can be said for monolith applications. If you've got this massive, bloody beast of a thing that does everything, at least you can just go PHP server start, or whatever the command is, and you've got the entire thing running, right? If you have service-orientated architecture, then you have to well, this one's Ruby, so we're going to do Rails S, and then this one's Node.js, so we're going to pray to God that NPM works today, and then this one's this other thing, and oh, that service updated, so I better pull that down, and oh, how do I run migrations on this one? And then one of them crashes and you don't notice. And if you can't run the entire stack locally with one command, then you will not have a very good app. It's just a joke. You're building on top of a house of cards of lies. And Circle is really helpful for this. If you have your entire stack running on Docker Compose, you can get Docker running on your Circle CI tests, so that when you have your Angular.js dashboard or Vue.js or whatever it is today, you can have that dashboard running against a legitimate stack, all in Composer, running on the Circle CI VM, or Travis, or whatever. But make sure you test the whole thing. And another cool approach for testing, which no one really does, has anyone heard of describe it syntax? There's that's like an elbow. That wasn't even a hand. I don't know. Yeah, there's one at the back. Great. 2. Cool. I'm glad you have. That's good news. So, yeah, describe it is something I've used a lot when I'm working with Ruby and Go, and it's in a bunch of languages. But PHP doesn't entirely have an implementation that is what I expect it to. I'm looking to see if I'm getting eyes there. Basically, it looks, I don't know, like this, kind of. This is Ruby. So you can describe your endpoints, and each endpoint will have a different description. And then you can do your tests. Now, one of the very cool things, this is a very basic, very simple describe it syntax, but you can describe what you're doing, and then you can do it. It is the same as a test. Now, one benefit over kind of doing this in PHP unit is you can put annotations in so you have a clear label of what the test is doing, but in RSpec, which this is, it will just give you a little string, so you can put whatever you want in there. And then you can run the delete API request, and it will do stuff. There's another good bit of advice. Make sure you always put symbols in there, so you're not just putting 204, 403, all that stuff, because no one knows what those numbers mean half the time. And you can get more advanced with it. So this is another one. On the same describe, I've just collapsed down that other test, and I've put it does not destroy a user when not properly authenticated. So in this case, I expect to get an error, and it'll be unauthorized. But you can stack things up, and you can get more and more complex, and you can put these contexts in. So you're saying, all right, we're going to hit this endpoint, and when I have this valid payload, then and let is basically just a variable. It's like a lazy load variable. So once you call payload there, it will make that and shove it in. And if you have a bunch of tests where you want to have a valid payload, you can just keep on doing that and then check for other stuff at the bottom. And if you want to say, OK, I'm going to invalidate this payload by just like removing one required value, you can just null out that one value in the payload, and you can do that. It saves you having this massive bloody test file with a bunch of very similar data providers. And anyone want to try and read that? Chrysalid Callan, I think. I don't know. That's the name of the project. And it's a really cool testing system. It uses the PHP unit assertions, I think, but it just gives you like a pretty cool runner, and it's got a pretty fancy output as well. So I recommend having a look at Callan. I think Chris Artjes is a bit of a fan as well. So one other random bit of advice that's caused the most problems out of anything is don't let other developers in your company develop against staging. Has this happened to anyone? Do people actively do this? It's the worst. The Riot API, even version 2, where we had a clean slate to do anything we wanted to, uses JSON API, RC3. Yay! The reason for that is that the API has been built, we built it so it could support, we kind of upgraded the API. But the problem was, because both the Android team and the iOS team were both developing against staging because we didn't have Docker set up at the time. They couldn't have the stack running locally. If they want the stack, they have to point at staging. Otherwise, it's QA or production, and that's terrible. So they were like actively working on features and developing and maintaining the application by pointing at staging. And that meant that unless both iOS and Android teams, both at the exact same time, like every person on those teams was completely ready to switch branches to the version that supported JSON API final, then they would just be broken and they couldn't do stuff. And we never got to that point where they were both ready at the exact same time. So we still are on JSON API RC3, and it's the daftest thing in the world. All that they had to do, all that needed to be done to avoid it is if we push a version of the API that supports it, and then locally they can just use whichever Docker tag they want, and they can keep on working on the old version for a little while. When they're ready to switch, they can then switch to the new one. So don't let people hit staging. Most of the answers for this is Docker, by the way. Anyone recognize what this is about? One of the kind of cool things that I liked about JSON API, and that I used to do with my APIs before I started liking JSON API. I'm not sure if it's Stockholm Syndrome. I'm not sure if it got better. But including stuff is kind of handy sometimes because, like I said, making a whole bunch of requests can be kind of scary. It can be really slow. It can be annoying. So a lot of people will end up adding includes. And they take whatever comes in the include get query string, and they just shove that into their ORM. And then it just includes whatever you put in there, which seems like a really handy, convenient feature at the time, but then people start to really misuse it, and you don't always know that they're misusing it because people don't tell you every single request they're making, and unless you're snooping on the developers in your team, then you might not notice that it gets pretty big. We had 2 of these. One of them, but both the iOS team and the web team, they both made this mega query of doom, and they were both huge, but they started at different places. So the iOS team started at users/me and then included trips, but then that included too many trips, so they were like filtering some of them out. But then they also wanted trip passengers and trip passengers avatars and trip passenger avatars of previous trips. And we had this massive query that took like 5 seconds to run. And I was like, you realize it would be much more performant and technically easier if we just sent you a URL where you could download a zip file of the database and then just run it locally in memory. Like, this is completely ludicrous. So the approach that we used to sort that out was we just deleted all the includes. We just pushed a version and went, and then what we've done is basically, as and when a use case comes up where having an include would be a logical choice and there is no better way of doing it, then we will add that to a whitelist, and we will pass that into the query, into the ORM, and we'll make sure that if you pass in an include that we've allowed, then it will preload that in the ORM using eager loading, so that it makes an efficient query, right? We went from having like 5-second page loads to having like less than half a second. And a lot of people don't really realize that a lot of the time making 2 requests is fine. Like, if you just make one request and then work out the things you want to hit and then make a second request, it often is quicker than just making one mega query of doom. So this is a pretty useful thing to do. Anyone know the company? Runscope. I've got one of those, and I forgot it. I'm not doing a very good job of pimping Runscope, but Runscope is amazing. One of the problems that you can run into is a user is using your application, and it doesn't work, and then you get an email saying, it doesn't work. And you're like, cool. It's pretty hard to work out what exactly is going on when something fails, unless to test your API, you need to know what headers to send, what URL to send, what their access token was, and like what they were doing. Like, what was the payload? What was the response? How does the response differ from what the iOS app is expecting, right? So there's no chance in hell you're going to get some random driver that commutes to work in Idaho to let you know what his access token was. So generally, keeping this stuff is pretty helpful. If you have Runscope, you can you have to manually put your traffic through it. So you have to configure the iOS app to send traffic through Runscope and send it off to your actual API. And that adds like a bit of time. It can add like 50 milliseconds, I think, if you don't get it right. But it's kind of worth it, especially when an app is fairly new, to do that. And you can turn it off and on, and you can set up service discovery so that if Runscope goes down, then you don't send it through it. But having Runscope on there really can give you information when otherwise you just not have any clue why things are broken. Anyone seen this stuff? Runscope, I thought they made this tool. I think they just bought it from someone, but whatever. Runscope Ghost Whisper, Ghost Inspector. So one thing that Runscope does, as well as their proxy service, they have something called Radar, which is like Pingdom, but not useless. So Pingdom's just like, there's a website there. Radar will be basically, if I send this payload, does this response come back? And you can make multiple requests to see that multiple things are working, and you can check for how long it took and everything else. If you use Runscope Ghost Inspector, they basically have a Chrome extension which you can just click on and then just click around your website. It's kind of like macros in some like VB.NET thing, but you can click around your website and it will record all the actions you've taken, and it will like save the form fields you put in as variables and like send them off, and it will run Radar in the background whilst you're doing that. So this is basically a fairly handy way of doing what you could do manually with a whole bunch of Selenium and all these other tests. Like you could do Behat and Selenium and all that stuff and write it all out manually, or you can just be like click, 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 yay. And maybe you can do both. You can have Selenium yourself, but the QA team could have that. So you can check what API requests are being made in the background whilst you're doing the web stuff. I really wanted to use Ghost Inspector, but we actually deleted our web app the day I planned on using it, so didn't get a chance. We just use iOS now, yay. And that, I think I smashed through the first half of my talk because I'm incredibly nervous. There's so many people and so many faces. But yeah, I got a book about this stuff. So if I spoke way too quickly, you can just read words instead. But if anyone has any questions, not about the framework interoperability group, please let me know. Any questions? No? Yeah.
It's not about fig. So you mentioned with the deep include that you have when you made a preloader. So just to give you an example, what I did is there's a fractal that is doing transform, and then we have almost exactly the same thing that is preload. So you have several classes that go inside, because you said you have a ride and then you have a traveler or whatever you call them, and then you have an avatar inside. So we did exactly the same thing, but it's just preloading. Is there a smarter way to do that, or you're doing something similar?
Yeah, we preload it. I mean, to whitelist, we're not doing anything fancy. There's literally, instead of passing the kind of include parameter directly in, we're just doing like an array diff on it. So as long as the things that you've said are, as long as the things you've tried to include are on this array, you're good to go. And preloading, yeah, we pass the. We'll pass in anything that you request to include into the preload, but that's fine because we've whitelisted the things that you're allowed to pass in. So as long as you whitelist, then just dumping that value into the eager loader is totally okay. Sometimes you have to do some fancy stuff. Like if you aren't actually using an ORM, then it's kind of hard to do eager loading, but you can like send that off to your repository or your whatever DDD stuff, and it's fine.
All right, thanks.
Anybody else? You can ask questions about the fig if you want. I mean, it's kind of beer time, so I'll probably be talking about the fig outside anyway, but...
Hi. Just a quick question on versioning. You mentioned that all kinds of solutions, but you didn't mention, I mean, the obvious solution for me, at least, is to include the version number into URL. What's wrong with that?
No, I mean...
Any objection?
If you search for Troy Hunt, versioning is wrong, then there's a whole bunch of stuff. Like, this talk isn't so much about telling you how to do stuff, it's just like arbitrary advice I threw together. I have a talk called API Pain Points, which is all over YouTube. I did it like 5 times at least on YouTube. And it talks about that stuff in more detail. It's also in my book. But generally speaking, the very short version of why doing it in the URL is wrong is it's kind of... The idea is that once you have a URL to something, that's its location on the internet forever, right? It's like a permalink. It's like it's going to be right over there.
Is it not ideal for public?
Yeah, it's not ideal, but the idea is that a lot of people they'll save the local copy of your data and they'll shove that into the database, and you can put the link in the database right there. So if you ever want to update the information, you know exactly where that thing is, and you can say the version I had. If you're versioning your resources, you can say I have version 3 of a ride, and it looks like you now have version 4 of a ride. So you can just kind of get version 4 and dump it in the database, and it's still in the same place. If you want to do that kind of self-updating data with a URL, with a version in the URL, then you basically have to like str replace the URL, which is gross. And that's kind of one problem with it. But it does get past a lot of other problems. If there are some headers that will be stripped by like library computer proxies. And so if you have the versioning in a random header, like an accept header, they quite often just strip that out. So there's a lot of pros and cons, and that's why they're all wrong, because they all have so many cons that it just sucks to version your API. So.
Okay, thank you.
I'm glad you have questions. I got through that first part way too quickly. Sorry if no one could understand me.
Hello, Ljubisha here. Can you tell us what is your best way to protect APIs? What tools you will use or something
What
like that?
sort of thing are you worried about protecting from? Like
Like
security
JWT
issues?
or something like that. What tools you
Oh,
will use?
JWT, so kind of like access control. Yeah, absolutely. I really like OAuth 2, and OAuth 2 gets a lot of flack because it's insecure if you don't have SSL. Use SSL. It's really complicated to implement yourself. Don't implement it yourself. Like, the arguments against OAuth 2, even by Aaron Hammer, are completely baseless as far as I'm concerned. There are things like the PHP League OAuth 2 server. You can just shove that in. You do have to kind of implement some of the stuff yourself, but you can have JWT tokens with OAuth 2. The benefit of OAuth 2 is that you can just use grant types. You can make a grant type for anything. You can make a social grant type, so you pass it your Facebook access token, and then it will create an account for you if you don't have one, or it will log you in if you already have one, and it will grab your avatar. Like, there's so many cool things. You can do like facial recognition OAuth 2, where you just send a photograph of your face, and it'll be like, hey, Phil, come on in. Like, it's the best thing around. For other sorts of protection, there's a lot of hosted services. Kong offer rate limiting, and that can really help, because if your app server is handling the rate limiting by itself, then it's still kind of accepting DDoS, and it's just DDoSing your Redis server while it's trying to find out how many hits you've got. So if you can put something in the way of your API to handle kind of attacks, then Kong and stuff like that is pretty good.
Thanks.
I know someone wants to ask me a question about the fig.
Have you ever seen Vance Lucas' Frisbee.js library? Do you have any thoughts on it?
Oh, yeah. I keep giving talks about APIs, and people keep saying, hey, you should use Frisbee, and then I keep going, cool, and then I go and drink and don't do it.
Anyone else?
That's it.
OK, thank you very much.